November 4th, 2025, 5:13 p.m., Louisville, Kentucky. A UPS McDonnell Douglas MD-11 cargo jet accelerates down runway 17R, engines screaming as 630,000 pounds of aircraft and fuel builds toward rotation speed. In 7 seconds, everything that can go wrong does. The left engine, a 28-ton turbofan spinning at thousands of RPM, rips completely away from the wing. Still on the ground, still accelerating. The pylon mount designed to handle millions of pounds of force just fails. Metal shears. The engine tumbles onto the grass beside the runway, carving a trench of fire and destruction. But the plane doesn't stop. It can't stop. The pilots are past V1, the point of no return. What happens next isn't just a crash. It's a cascading nightmare that will ground every MD-11 on planet Earth within 4 days and expose a terrifying question that nobody wants to answer. How many other planes are flying with a hidden defect that could kill everyone on board? Flight 2976 was supposed to be routine. 3 experienced crew members, a 10-hour flight to Honolulu, standard cargo, packages, documents, the kind of everyday shipments that move through the UPS Worldport facility in Louisville every single night. This facility processes over 2 million packages daily. It's the beating heart of global logistics. And on this particular Tuesday afternoon, as the sun hung low over Kentucky, nobody had any reason to think this flight would be different from the thousands that came before it. But when that engine separated, it didn't just fall away cleanly. It severed hydraulic lines, it ruptured fuel tanks in the wing, it created an instant inferno that began consuming the entire left side of the aircraft while the plane was still rolling down the runway at 140 miles per hour. Witnesses on the ground saw the fireball erupt. They saw the massive cargo jet continue to accelerate, trailing flames like a comet. The pilots had one choice: try to get airborne with a crippled, burning aircraft, or stay on the runway and almost certainly die in an explosion that would consume the cockpit within seconds. They pulled back on the yoke. The MD-11 lifted off, but this wasn't flight. This was a brief, doomed struggle against physics. The plane climbed to just 475 feet, barely higher than a 40-story building. The left wing was engulfed in flames. The asymmetric thrust from losing the left engine was forcing the aircraft into a violent left bank. And then the second catastrophic failure hit. The tail-mounted engine, the number 2 engine that sits at the base of the vertical stabilizer, started failing. Investigators would later find evidence that it had ingested debris from the first engine, or been damaged by the intense heat and shrapnel. Now the plane had lost 2 of its 3 engines. It was carrying maximum fuel for a trans-Pacific flight. And it was on fire. What the people on the ground saw next will haunt them forever. The MD-11 began descending, its trajectory shifting from a controlled climb to something that looked more like a controlled fall. The nose dropped. The left wing dipped lower, and then the plane started hitting things. First, it clipped the roof of a UPS Supply Chain Solutions warehouse, tearing a 300-foot gash in the metal structure and sending debris raining down on workers inside. Then the left wing smashed into fuel storage tanks at Kentucky Petroleum Recycling. The explosion was immediate and massive, a detonation that could be heard for miles, that sent a mushroom cloud of fire and black smoke hundreds of feet into the Kentucky sky. The impact rolled the aircraft past 90 degrees, and then it came down. The MD-11 crashed into a parking lot filled with semi-trucks and an auto salvage yard called Grade A Auto Parts. The landing gear was still extended. The plane hit nose first, then belly, then disintegrated across 800 meters of industrial property. All 3 crew members died instantly, but the horror didn't stop there. 11 people on the ground were killed, 11 people who were just working, just going about their Tuesday afternoon, just trying to make a living. One of them was 3 years old. A child, 3 years old, 15 more were rushed to hospitals with burns, trauma, crush injuries. Multiple buildings were obliterated. Families lost everything in the fires that spread from the crash site. Schools across the entire district were closed the next day. Shelter-in-place orders went out for a 5-mile radius as toxic smoke billowed across residential neighborhoods. Louisville Fire Department deployed over 100 firefighters to battle blazes that burned for hours, fueled by jet fuel and the thousands of gallons of petroleum products stored at the recycling facility. But here's where this story takes a turn that nobody expected. Within 96 hours of the crash, Boeing, which now owns the MD-11 design after acquiring McDonnell Douglas, issued an unprecedented recommendation: ground the entire global fleet. Immediately, the FAA followed with an emergency airworthiness directive. Every single MD-11 still flying commercial operations was ordered to cease flights pending comprehensive inspections. UPS grounded its MD-11 fleet. FedEx grounded theirs. Western Global Airlines grounded theirs. In one coordinated action, approximately 150 cargo aircraft, the workhorses of overnight shipping and international freight, were pulled from service simultaneously. The ripple effects were instant and catastrophic. Memphis International, the FedEx super hub, saw operations crater overnight. Package delivery delays cascaded across the United States and internationally. Supply chains that depend on just-in-time air freight started showing strain within 48 hours. Industry analysts estimated daily economic losses in the tens of millions of dollars. And this all happened during a partial federal government shutdown, which complicated the investigative response and regulatory coordination at exactly the wrong time. Why would Boeing and the FAA take such drastic action? What did they see in the wreckage of Flight 2976 that terrified them enough to ground an entire aircraft type that had been flying for 35 years? The MD-11 was supposed to be safe. It was designed with redundancy, 3 engines instead of 2, systems that could compensate for failures. The engine-mounting pylons, the structures that attach those massive turbofans to the wing, were engineered to handle forces that should never occur in normal operations. They're built with multiple attach points, fail-safe mechanisms, redundant load paths. They're tested and inspected and certified. So if you're watching this and you've ever flown on a plane, or if you've ever received a package that came via air freight, or if you've ever trusted that the engineering behind modern aviation is sound, you need to subscribe to this channel right now, because what we're about to uncover in the rest of this investigation is going to challenge everything you thought you knew about aviation safety. The National Transportation Safety Board arrived on scene within hours. They recovered both black boxes, the cockpit voice recorder and the flight data recorder. What those devices captured in the final moments of Flight 2976 included something that investigators specifically mentioned in their preliminary report: a persistent bell sound in the cockpit. What does that mean? What warning was the plane trying to give the pilots? And more importantly, was there any warning at all before the engine mount failed, or did this happen with zero indication that anything was wrong? The separated engine was found in the grass along runway 17R. It was photographed, it was catalogued, and teams of metallurgists, aerospace engineers, and accident investigators began examining every fracture surface, every bolt, every piece of metal, looking for the smoking gun. Because somewhere in that wreckage is the answer to a question that has grounded 150 airplanes and killed 14 people. What failed? How did it fail? And are there other planes flying right now with the exact same hidden defect waiting to kill again? To understand how catastrophic the failure of Flight 2976 really was, you need to understand the MD-11 itself. This isn't some experimental aircraft. This isn't a plane with a sketchy safety record. The McDonnell Douglas MD-11 is the descendant of one of the most successful wide-body jets ever built, the DC-10. When the MD-11 entered service in 1990, it was designed to be the ultimate evolution of the Trijet concept. 3 engines, long-range capability, massive cargo capacity. It was supposed to be the reliable workhorse that would carry freight across oceans for decades. And it did. For 35 years, MD-11s moved cargo and passengers around the world. UPS operates 57 of them. FedEx has a fleet. Western Global Airlines relies on them. These planes fly every single night, carrying everything from documents to medical supplies to parts that keep global manufacturing running. The MD-11 fleet has accumulated tens of millions of flight hours. And engine separations? They don't happen. Not on modern commercial jets, not during normal operations. The aircraft that became Flight 2976, registration number N259 up, rolled off the McDonnell Douglas assembly line in 1991 as a passenger jet for Thai Airways. It flew for 15 years, carrying people across Asia and the Pacific before UPS bought it in 2006 and converted it to a freighter. By November 4, 2025, this plane had logged 58 584 flight hours and 10 597 takeoff and landing cycles. That's 34 years of service. That's a lot. But here's the thing. Properly maintained aircraft can fly for 40, 50, even 60 years. Age alone doesn't make a plane dangerous. What makes investigators nervous is what happened in the weeks before the crash. N259 up was on the ground in San Antonio, Texas from September 3rd to October 19th. 46 days of downtime. Was it undergoing maintenance? Were the engines serviced? Were the mounting pylons inspected? The NTSB is pulling every maintenance record, every work order, every inspection sheet from that period. Because if someone made a mistake, if someone cut a corner, if someone failed to torque a bolt to the correct specification, that error just killed 14 people. But there's another possibility that's even more terrifying. What if the maintenance was done correctly? What if there's a defect in the design itself or in the manufacturing process that nobody caught for 35 years? What if there are dozens of other MD-11s flying right now with the exact same weakness waiting to manifest? This is why understanding the history of engine separations is critical. In 1979, American Airlines Flight 191, a DC-10, lost its left engine during takeoff from Chicago O'Hare. The engine flipped up and over the wing, severing hydraulic lines and destroying flight controls. The plane rolled inverted and crashed, killing all 271 people on board. It was the deadliest aviation accident in U.S. history at the time. The cause? Improper maintenance. American Airlines and Continental Airlines had been using a shortcut when changing engines, removing the engine and pylon as a single unit with a forklift instead of following the manufacturer's procedure of removing them separately. This created microscopic cracks in the pylon structure that eventually propagated to catastrophic failure. After American 191, the industry changed. Maintenance procedures were rewritten. Inspection protocols were enhanced. The DC-10's successor, the MD-11, was designed with all the lessons learned from decades of Trijet operations. Engine pylons were built with multiple attachment points, redundant load paths, fail-safe mechanisms. They're subjected to stress testing that simulates forces far beyond anything they should ever experience in normal flight. These components are inspected regularly. They're designed to never, ever fail. So when the left engine of Flight 2976 separated during takeoff roll, not from an explosion, not from a bird strike, not from foreign object damage, but from apparent structural failure of the mounting system, it sent shockwaves through the aerospace industry. Because if an engine pylon can fail on a properly maintained MD-11 during a normal takeoff, what else can fail? What other supposedly fail-safe components are operating closer to their limits than anyone realizes? The aircraft lifted off runway 17R with the left engine already gone and the wing on fire. The pilots had no time to process what was happening. 1 second they're accelerating normally. The next second there's a catastrophic failure, asymmetric thrust, fire warnings screaming, and they're committed to getting airborne because stopping is no longer possible. The cockpit voice recorder captured everything. The NTSB has it now. Whatever the pilots said, whatever warnings the aircraft gave them, whatever final desperate actions they attempted, it's all preserved on that recorder. After the crash, when the NTSB arrived and began photographing the scene, they found the separated engine in the grass beside runway 17R, approximately 700 feet from the departure end. It came to rest on its side, heavily damaged, with parts of the nacelle and fan cowl scattered nearby. This engine, a GE CF680C2 turbofan, weighs approximately 28,000 pounds and produces 61,500 pounds of thrust. It's a proven design that powers not just the MD-11, but also Boeing 747s, 767s, and Airbus A300s. Hundreds of these engines are in service worldwide. And now, metallurgists are examining every fracture surface of the attachment points, looking for the telltale signs that will reveal whether this was fatigue, corrosion, manufacturing defect, maintenance error, or something else entirely. But here's what's keeping safety officials up at night. The CF6 engine has a documented history of problems. The GE CF680C2 engine that powered Flight 2976 has a history that aviation safety experts have been quietly worried about for years. Multiple incidents of engine fires, uncontained failures, events where turbine blades punched through engine casings and sent shrapnel into fuel tanks and control systems. In 2006, a FedEx MD-11 experienced an engine fire on approach to Memphis. In 2011, an Atlas Air MD-11 had an engine failure over the Atlantic. These weren't crashes, but they were warnings. Red flags that something about this engine-aircraft combination required constant vigilance. But fires are one thing. Complete structural separation of an engine from the wing during takeoff, that's a different category of nightmare. And now investigators are zeroing in on exactly how it happened, because the answer will determine whether this was a one-off tragedy or a fleet-wide crisis. According to sources close to the investigation, the focus is on the engine mounting system itself. 3 mounts secure each CF6 engine to its pylon, the structural beam that connects the engine to the wing. 2 forward mounts and 1 aft mount. These aren't simple bolts. They're precision-engineered attachment points designed to handle millions of pounds of force, while also allowing the engine to move slightly during flight to accommodate thermal expansion and aerodynamic loads. The system is designed with a critical safety feature. In the event of a catastrophic engine failure, the mounts can allow the engine to break away from the wing entirely, preventing damage to the aircraft structure. But here's the key. If an engine separates while still producing thrust, it's supposed to rotate upward and travel over the top of the wing, away from the aircraft. The design anticipates this. It's engineered for this specific failure mode. What it's not designed for is the engine dropping downward and tearing through the wing while the aircraft is still on the ground, rupturing fuel tanks and severing hydraulic lines before the pilots even have a chance to respond. The evidence recovered from runway 17R is now under intense scrutiny. Metallurgists are examining every fracture surface on the separated pylon and mount points. They're looking for specific patterns. Fatigue cracks show distinctive beach marks, progressive fractures that grow slowly over time until catastrophic failure. Corrosion produces characteristic pitting and material degradation. Manufacturing defects leave telltale irregularities in the metal structure. And improper installation or maintenance can result in stress concentrations that cause sudden brittle failure. What they're trying to determine is whether the engine struck the pylon first, meaning an engine mounting bolt or pin failed and allowed the engine to shift before ripping the entire pylon away. or whether it was a clean separation, with the pylon attachment failing first and the engine dropping as a complete unit. The difference matters enormously. If a mounting pin failed, investigators need to know if it was a maintenance error, a defective part, or a design flaw. If the pylon structure itself fractured, they need to know if it was fatigue, corrosion, or something else that wasn't caught during inspections. Some components have already been recovered. Some mounting pins have been found in the grass, but other pieces are still missing, buried in the debris field, or consumed by fire. Teams are searching through thousands of pounds of wreckage, cataloguing every fragment, because somewhere in that twisted metal is the physical evidence that will answer the question everyone is asking. Why right now? 59 MD-11s sit grounded at airports across the United States. Another handful are parked internationally. Every single one of them is waiting for inspections that haven't been fully defined yet, because investigators still don't know exactly what they're looking for. They know the left engine and pylon separated. They know it happened during takeoff roll. They know it was catastrophic. But the why, that's still being pieced together from wreckage and data. The cockpit voice recorder and flight data recorder were recovered within hours of the crash. Both were sent to the NTSB laboratory in Washington, D.C., where specialists extracted the data and began analyzing every millisecond of Flight 2976's final moments. What they found was both enlightening and disturbing. The flight data recorder showed normal engine parameters right up until the moment of separation. No warning, no gradual degradation. The engine was performing normally, producing thrust, operating within specifications, and then it wasn't. It was just gone. The cockpit voice recorder captured the sounds inside the flight deck, the routine call-outs as the aircraft accelerated, the sudden change in engine noise, and then that persistent bell sound that the NTSB specifically mentioned in their preliminary briefing. Aviation experts have been analyzing what that bell could mean. On the MD-11, different warning tones indicate different emergencies. A bell can signal fire, it can signal system failures. It can indicate multiple cascading problems demanding immediate attention. Whatever that bell was warning the pilots about, they had seconds to process it before their aircraft became unflyable. But here's where the investigation takes a turn that changes everything. Remember how N-259-UP was down for maintenance in San Antonio from September 3rd to October 19th, 6 weeks of downtime. The NTSB is now pulling every single maintenance record from that period. Every work order, every inspection sheet, every mechanic who touched that aircraft. And they're finding something interesting. The aircraft had documented issues with fuel tanks and fuselage components during that maintenance period. Those issues were addressed, but investigators are now asking a more fundamental question. Was engine pylon work performed during that maintenance? Were the engine mounts inspected? Were any components replaced? And here's what makes this so critical. If maintenance work was done on the pylon or mounting system, and if that work was done incorrectly, a bolt not torqued to specification, a pin not properly seated, a critical inspection step skipped, then this crash isn't a design flaw or manufacturing defect. It's human error, and that means the other MD-11s in the fleet might be fine, as long as they weren't maintained by the same facility using the same procedures. But there's another possibility that's even more disturbing. What if the maintenance was done correctly, but the inspection protocols themselves are inadequate? What if there's a failure mode that current inspection procedures don't detect? Fatigue cracks can propagate below the surface of metal components, invisible to visual inspection, undetectable except through ultrasonic or X-ray testing. If the MD-11 fleet has been accumulating hidden structural damage in the pylon attach points for years, and if current inspection intervals aren't catching it, then every single MD-11 flying could be a ticking time bomb. The NTSB is now going back through the entire maintenance history of N-259-UP, not just the recent work in San Antonio, but years of records. They're examining CCTV footage from the San Antonio facility to see who had access to the aircraft and what work was performed. They're interviewing every mechanic, every inspector, every supervisor involved in that maintenance period. They're leaving nothing to chance. Simultaneously, metallurgists at the NTSB's materials laboratory are examining the fracture surfaces of the recovered pylon components. Using electron microscopy and other advanced techniques, they can determine whether the failure was sudden or progressive, whether it initiated from corrosion or fatigue, whether there were pre-existing cracks that were missed during inspections. Every grain of metal tells a story. Every fracture pattern reveals information about how and why it failed. And Boeing is conducting its own parallel analysis. They're running finite element models of the pylon structure under various load conditions. They're reviewing their original design calculations from the 1980s. They're examining data from other MD-11s in service, looking for any hints of similar degradation. Because if there's a design flaw they missed 35 years ago, they need to find it before another engine separates and kills more people. The stakes couldn't be higher. 14 people are dead, 59 aircraft are grounded, global supply chains are strained, and somewhere in the wreckage of Flight 2976 is the answer that will determine whether the MD-11 ever flies again. As of November 11, 2025, 1 week after Flight 2976 crashed, the investigation has entered its most critical phase. The NTSB has completed preliminary examinations of the cockpit voice recorder and flight data recorder. They've catalogued thousands of pieces of wreckage. They've interviewed witnesses, reviewed maintenance records, and begun metallurgical analysis of the failed components. And while they haven't released a definitive cause, what they have revealed is deeply troubling. The flight data recorder shows that all 3 engines were operating normally right up until the moment of separation. There were no abnormal vibrations, no temperature spikes, no oil pressure drops, none of the warning signs that typically precede an engine failure. Whatever happened to the left engine pylon, it happened suddenly and without warning. 1 second, everything was normal. The next second, a 28-pound engine was tumbling down the runway, and the aircraft was on fire. The cockpit voice recorder captured the pilot's final moments. The NTSB hasn't released the full transcript, but investigators have confirmed that the crew followed emergency procedures exactly as trained. They identified the problem. They attempted to maintain control. They fought to save their aircraft right up until impact. These weren't novice pilots caught off guard. These were experienced professionals who did everything right, and it still wasn't enough. Because when you lose 2 engines during takeoff with maximum fuel load and your wing is on fire, there are no good options. There's only physics, and physics doesn't care how skilled you are. The metallurgical analysis is still ongoing, but preliminary findings suggest the failure initiated at one of the forward mount attach points. Whether this was due to fatigue, corrosion, manufacturing defect, or maintenance error remains undetermined. What investigators do know is that once the first mount failed, the cascading loads on the remaining mounts exceeded their design limits almost instantly. The pylon didn't gradually deteriorate. It catastrophically separated in a fraction of a second. The broader implications are staggering. The MD-11 has been flying for 35 years. It's accumulated tens of millions of flight hours across hundreds of aircraft. And if this failure mode has existed the entire time, undetected by routine inspections, hidden beneath layers of metal and composite structure, then every one of those flights was operating with an invisible risk that could manifest at any moment. The question keeping aviation safety officials awake at night is whether Flight 2976 was the first time this failure occurred, or just the first time it resulted in a crash. The economic impact of the grounding continues to ripple across global supply chains. UPS has rerouted cargo to other aircraft, but with 25 MD-11s out of service, capacity is strained. FedEx, with 29 grounded MD-11s, faces similar challenges. Packages that normally move overnight are taking 2 or 3 days. Medical supplies, critical parts for manufacturing, time-sensitive documents, all delayed. Industry analysts estimate the daily economic impact in the tens of millions of dollars. And there's no timeline for when the MD-11 fleet will return to service, because investigators still don't know what corrective actions will be required. Boeing has remained largely silent beyond their initial recommendation to ground the fleet. They're conducting their own engineering analysis, reviewing decades of design documentation, running computer simulations of various failure scenarios, but they haven't issued any guidance on what operators should inspect for or what fixes might be necessary. Because they don't know yet. Nobody knows. And then there are the families, 14 families, who lost someone on November 4th. 3 crew members who went to work that day expecting to fly to Honolulu and come home. 11 people on the ground who were simply living their lives and working in warehouses, driving trucks, trying to make ends meet. A 3-year-old child who will never grow up. These aren't statistics. These are human beings whose lives ended in seconds because something failed that was never supposed to fail. The investigation will continue for months, possibly years. Eventually, the NTSB will publish a final report with findings and recommendations. Changes will be made. Inspections will be mandated. Maybe the MD-11 will fly again with enhanced safety protocols. Maybe it will be permanently retired from service. But none of that will bring back the 14 people who died. What Flight 2976 has exposed is a fundamental truth about aviation that the industry works desperately hard to ignore. We are always one hidden defect away from catastrophe. We design aircraft with redundancy. We inspect them meticulously. We train pilots to handle emergencies. We build systems upon systems upon systems, all intended to ensure